Morning, everyone. This is Vijay Kumar from the Department of Mechanical Engineering in second year, second semester, bearing roll number 254G580310. Today, I am going to present my seminar on the topic of comparison of balanced and unbalanced rotating system on the subject of theory of machines, regulation R23. The topic is comparison video of balanced versus unbalanced rotating systems. The small introduction to a rotating systems. Rotating systems are commonly used in machinery such as turbines, motors, and fans. Proper balance in these systems is essential for efficient operation and longevity. This presentation compares the characteristics and effects of balanced versus unbalanced rotating systems. What is rotating systems? Like this, balanced rotating system and unbalanced rotating system. Here the point circle, the axis of longitudinal axis is around the midpoint is totally balanced system, where the rotation about the center. And unbalanced rotating systems are the rotating plus orbit. Examples are this. What is balanced rotating system? Before this, we discuss about what is a rotating system. A rotating system is an mechanical system in which components rotates about an axis. Examples include motors, electric motors, car gates, turbines, ceiling fans. Yes, ceiling fan is the example of we are all see ceiling fans in our houses, homes, anywhere. These are the best examples. In these systems, the distribution of mass plays very important role in performance. Balanced rotating system. What is balanced rotating system? A balanced now let us understand what is a balanced rotating system. This rotating system is said to be balanced when the mass is evenly distributed around of axis. Balanced rotating system has mass distribution evenly spread around its axis of rotation. Due to this, there is no unbalanced force acting on the system. This uniform distribution minimizes the generation of dynamic forces distributions rotation during rotation. In simple words, the system rotates smoothly without vibration. For a system to be perfectly balanced, two conditions must be satisfied. The sum of all forces must be zero. Examples this. A balanced system and unbalanced system. The balanced system versus unbalanced systems, the line diagram is. Balanced systems tend to operate smoothly with reduced vibrations and noise. The sum of all forces must be zero. We discussed, and the sum of all movements must all be zero. This ensures that there is no shaking or wobbling during rotations. Also, characteristics of now I will explain the characteristics of balanced system. A balanced rotating system has the follow features: smooth and stable rotation, less noise, no vibration, longer mission life, high efficiency. Because of these advantages, engineers always try to design mission in a balanced condition. And we will discuss about now what is unbalanced rotating systems. Unbalanced rotating systems as uneven mass distribution leading to excess centrifugal forces. Now let us understand the unbalanced rotating system. A system is said to be unbalanced when the mass is not evenly distributed about the axis of rotation. Due to this uneven distribution, a centrifugal force is generated which causes vibration and instability. This vibration increases the speed and can become very dangerous in high-speed missions. Yes, this forces causes vibration which exhibits wear and damage to components. Unbalanced systems often require corrective measures to prevent operational events. The static unbalance and dynamic unbalance. The causes of imbalance in rotating system, manufacturing imperfection can lead to slight mass inconsistencies, accumulate of corrected rubbish or weight can increase imbalance over time. Incorrect assembles or damage to quad can also create imbalances. The difference between the unbalanced force due to reciprocating mass and that of rotating mass. Unbalanced force due to reciprocating and unbalanced force due to rotating. The difference is the reciprocating and rotating. The unbalanced force varies in magnitude but constant in direction. The shaking force produces linear vibrations of the frame in horizontal direction. Only a fraction of reciprocating mass can be balanced. An unbalanced force due to rotating mass. The unbalanced force is constant in the magnitude but varies in direction. Complete balance of prevailing mass can possible. Effects of balance on system performance. Proper balancing reduces vibrations, leading to smooth operation, decreases mechanical stress, extending equipment life. Balanced systems consumes less energy and operate more efficiently. Centrifugal forces are unbalanced. The main reason for vibration in unbalanced system is centrifugal force F equals to mr omega cube omega square. From the equation m is mass, r is radius, and omega is angular velocity. Consequences of unbalanced in rotating systems. Yes, we discuss all this. Types of unbalanced are rotating and static and unbalanced, dynamic and unbalanced. Excess vibrations can cause noise and discomfort during operation. Unbalanced accelerates bearing weight and can lead to premature failure. It may also cause structural damage to machinery and supporting structures. The rotating imbalance M equals to capital M equals to total mass, small m equals to unbalanced mass, E equals to resistance. Methods of balancing rotating systems. Static balancing involves adjusting the mass distribution to eliminate imbalance at rest. Dynamic balance considers the system in motion, providing more precise correction. The techniques include adding counterweights or using balancing missions for measurements and correction. The example is the diagram had a rotor and the shaft. A is rotor and B is the shaft. And the parameters of rotating bodies or rotor and shaft is L equals to length of the rotor or shaft, D equals to diameter of rotor or shaft, and L suffix S is length of the rotor or shaft, diameter, and A equals to diameter, M equals to mass, and M suffix DF equals to unbalanced mass in the plane, M suffix D2 equals to unbalanced mass in the plane 2, L suffix 1 is the distance of the plane of 1 for placing the unbalanced mass into LT and L2. Our transversal polar momentum inertia. Impact of balance on maintenance and cost. Well balanced systems require less maintenance and experience fewer breakdowns. Imbalance can lead costly repairs and downtime due to equipment failures. In unbalanced system, because of vibrations or instability, the repair should be costly and the downtime due to equipment failure. Investing in proper balancing reduces long-term operational expenses. If you balance the machineries and investing in the balancing, proper balancing, reduce long-term operational expenses. And the effects we all discussed unbalance cause many serious problems that are excessive vibrations, bearing failure, noise generation, reduced efficiency, structural damage, increased maintenance costs. In extreme cases, it can lead to complete mission failure. Summary and conclusion. Before summary and conclusion, methods of balancing is static balancing and dynamic balancing, use of counterweights, already discussed. And the applications of the rotating systems or balancing is used in many real life applications. Automobile engines and the vehicles are used balancing rods, balancing. equipments, and also in the turbine in power plants and the fans and bowl blowers, motors and the shafts. Without proper balancing, these machines cannot function efficiently. And let's discuss on about conclusion. And summary, proper balance in rotating systems enhances performance, safety, and durability. Unbalanced systems pose a risk of damage, higher maintenance, and higher efficiency. Balancing, let's discuss to conclude, balancing rotating systems are essential for smooth, efficient, and safe operation missions. Unbalanced systems lead to vibration and noise and damage. Therefore, proper balancing should be must. Balancing is a key aspect in mechanical design and the maintenance. Understanding this concept helps engineers improve mission performance and reliability. And the unbalanced system pose risk of damage, higher maintenance, and the inefficiency. So the regular inspection and balancing are vital for optimal machinery operation. And ending, thank you for listening to my presentation. I hope you understand the concept clearly. Now I'm ready references for and thank you for listening.